All right, hello, sixth period. So as I have been saying previously, I unfortunately am not able to be there today, just due to I have an appointment. However, I will see you tomorrow for pajama day. Very excited. But today we're just going to be getting more practice solving systems of equations. We looked at a few different ways to actually solve them, and so now you're just going to kind of go through and get some practice. And so you hopefully should have already started to do now. If not, go ahead, take 5 minutes to start that do now. You can pause here. If that do now is already done, perfect. We're going to quickly go over it. Now, for number one, we have that the graph of the system of linear equations is shown below. What is the solution to the systems? Well, every time we have a graph, remember, when we talk about the solution to a graph, what we're really looking for, I know we've wrote this before, but we're going to make another note of it. It's our point of intersection, right? We're looking for where do those two lines actually collide. And I can see it's going to be happening right there. And so that point, well, that's -1 there, and that's 1. And so I'm looking at the point -1, 1, which is option D. Now, taking a look at number 2, we have two equations that are both in slope-intercept form. Remember, right, we made that wonderful stamp on Tuesday. When we have two systems in slope-intercept form, what we're going to do is we're just going to go ahead and set them equal. And so I'm going to have 5x minus 4 is equal to -2x plus 17. And from here, I can just solve for x. And so I'm going to start right away with some inverse operations. I'm going to opt to add 2x to both sides. I'm going to have 7x minus 4 is equal to 17. From here, I'm going to go ahead and I'm actually going to add 4 to both sides. Got to get that constant over there. What I'm going to have left, 7x is equal to 21. Well, from here, I can now divide by my coefficient, which is going to be 7, to learn that x is equal to 3. Fantastic, but remember, we're not done yet. Now, both of these equations look fairly similar, so I'm just going to go ahead and take the first one, and so I'm going to use y is equal to 5x minus 4. Only now I'm going to substitute that 3 in for x. And so y is going to be equal to 5 times 3 minus 4. And so I'm going to have 15 minus 4, which means that y is going to be equal to 11. And so we want to make sure that we are writing this as our point. Our solution is 3, 11. Fantastic. All right, so what you're going to do now is that you're going to have an extended period of time to go through and just try out some practice problems. You're going to have the ability to work through both problem set A and problem set B on your own. The goal here is just to get as many at-bats as possible, get as many practice problems in, because next Friday, as I know we've been over so many times, you have your IA, which is super exciting, but also means that we do have to have this down. So go ahead and turn to problem set A as I slowly scroll down to it. Here it is. Start with question number 1. Work your way through all the way through problem set B. By the time you get back to me, you will have hopefully had that extended time, and I will be going over all these problems. Go ahead and pause the video. All right, so we're going to go over all of these problems. And anything that you aren't sure of or anything that you have wrong, please make sure you're just writing with me. If at any point you need the video paused, raise your hand, ask whoever's filling in for me to pause it, go back, and you can rewatch me solve it. So, number 1, we have this system of equations. Now, we're being specifically asked to graph these, and so we want to be able to do that. When we are graphing these, remember, we need to pull out 2 pieces of information. First piece, slope. I know that my slope is going to be 3 there. And the second piece is going to be my y-intercept. My y-intercept for that first equation is going to be 0, -7. Awesome. We're going to actually just go ahead and graph this first line before we do anything else. Find 0, -7. There it is. It's the first thing that goes on the graph. There's my point. And now, for a slope of 3, remember that's the same thing as 3 over 1. And so I'm going to go up 3 and to the right 1. So I'm going to go 1, 2, 3, 1. Put another point right there. 1, 2, 3, 1, put another point there, and 1, 2, 3, 1, put another point right there. Now I'm going to use a dotted line just because unfortunately my ability to draw a straight line on this Word document is less than great. There we go. There's our first line. Now I'm going to do the same thing only with the second equation. Slope is going to be -2, and my intercept is going to be 0, 8. Come up here, plot 0, 8, down 2 over 1, down 2 over 1, and down 2 over 1. Now, by doing so many dots, I know that when I draw this one in, that point right there is going to be my point of intersection, and so that point is 3, 2, which means that my solution is 3, 2. Looking at number 2. Now, number 2 is what we did just yesterday. I have one equation in standard form, and I have one in point slope form. Or sorry, slope intercept. Apologies. And so I'm going to go ahead. I'm going to find that y is already isolated. And so I'm going to take this -2x plus 7 and plug it right in for my y. And so I'm going to have 3x minus 6, parentheses, -2x plus 7, close those parentheses, is equal to 18. From here I have to distribute, and so I have 3x plus 12x minus 42 is equal to 18. I'm going to go ahead and combine my like terms. 15x minus 42 is equal to 18. Add 42 to learn. 15x is equal to 60. Divide by 15. X is equal to 4. I'm going to take this, plug this back in. Remember, when we are looking to plug this back in, we should always use the equation that already has our variable isolated. It's just going to be easier. We don't have to worry about inverse operations. It's going to save us time. And so I'm going to have that y is equal to -2x plus 7. Just carve out a space. I'm going to take this 4, plug that in. So we're going to have -2 times 4 plus 7. That means that y is going to be equal to -8, again, plus 7. Which means that y is equal to -1. Which means that my solution, and please make sure you're not switching these, is 4, right? Because that's my x value, -1. All right, taking a look now at this next problem. Once again, we have same setup. We have one standard, one slope intercept. So I'm going to go ahead and do that same thing. 2x plus 3 parentheses, 3x minus 7, right, because y is already isolated, is equal to 12. Distribute 2x, plus 9x minus, apologies, not 7. I didn't distribute properly. Minus 21, there it is equal to 12. Go ahead and combine these terms. 11x minus 21 is equal to 12, plus 21 on both sides. 11x is equal, well, 12 plus 21 is going to be 33. Divide by 11 to learn that x is equal to 3. Again, go ahead, plug this right into that equation, which is already isolated. Y is equal 3x minus 7. That's the one I'm going to use, which means that y is equal to 3 times 3 minus 7. As we all know, 3 times 3 is going to be 9 minus 7, which means that y is equal to 2. And once again, I know this is on the left and that's on the right, but let's not accidentally flip these. My solution is going to be 3, 2. All right, moving on to number 4. Similar to number 1, except that half of the work is kind of already really done for us. So the first equation is already graphed. Awesome, I don't have to worry about that one. I'm just going to put a little check mark there. Fantastic. And now I'm going to do the same thing we did up with 1 with pulling out my slope and y-intercept. And so I know that m is going to be equal to 4, and I also know that the intercept is going to be 0, 1. Let's go ahead and plot that. find 0, 1. There it is. We're also going to go 1, 2, 3, 4 to the right 1. 1, 2, 3. Oh, I'm out of spaces. Well, luckily, as we've talked about before, instead of going up and right, let me put that over 1 just so it's a little bit clearer, I can also go down and left. We've talked about this before, and so I'm actually going to go down and left to put my next few points just because there's more space. 1, 2, 3, 4, 1. There it is. And 1, 2, 3, 4, 1. There it is. And so hopefully by now you saw, hey, look, we put a point directly on that line. And so odds are really, really good that that point is going to be our lovely point of intersection. And so that point is, let's take a look, left 2, down 7. I'll write it down here. -2, -7. All right. Let's move on to problem set B. Once again, in 1, we have 2 equations in slope-intercept form. We're just going to go ahead, set them equal, and then go ahead and solve for x. So we're going to have 6 minus 4x is equal to -2x minus 2. Going to add 4x to both sides. 6 is equal to 2x minus 2. Add 2. 8 is equal to 2x. Divide both sides by 2. Learn that x is equal to 4. We're going to take that. We're going to plug that into, again, either one works. I'm going to opt for the second one, or sorry, the first equation. And so I'm going to have y is equal to 6 minus 4x. And so I'm going to have y is equal to 6 minus 4 times 4. Well, we know that 4 times 4 is going to give us 16, so y is really 6 minus 16, which means that y is equal to -10. And so my solution is 4, -10. All right, looking at number 2. Now, we have one equation in standard form. We do also technically have a line and slope intercept. The only thing about this line right here, right, this first equation, y is equal to -2, it technically has a slope of 0, which means that we're actually looking at a horizontal line. Now, this is going to be actually very similar to the very first part of our notes from yesterday, where we looked at what we kind of considered to be like the more simple example. And so I'm going to actually take this -2, and just like we've been substituting, it's going to be substituted right in for y. And so I'm actually just going to have 4x minus 3 times -2 equals 18. Well, 3 times -2 is going to be a positive 6. Negative times a negative is a positive. So we have 4x plus 6 equals 18. Go ahead and start inverse operations by subtracting 6. 4x is equal to 12. Continuing inverse operations. Oop, I don't want to divide by 12. I want to divide by 4. There it is. Divide by 4. To learn that x is equal to 3. And so now, the fun part of this is that we actually don't have to substitute this x back in to find y. The reason for that is we're told what y is. Y right away is -2, which means that I actually already have my coordinate point. My coordinate point, or my solution, is going to be 3, -2. All right, now, the next 2 questions are going to be done very similarly to what we've seen. If you have questions about those, I will be able to go over them on Friday, but for the sake of time, you're going to go ahead and take a look at that exit ticket. Now, I don't want you to freak out. On the exit ticket, yes, it says quiz. Don't worry, I'm not grading it like a quiz. That's just the way that the packet was set up. But I want you to go through, solve these 2 questions. This is definitely something I will be looking at. You have until the end of class. Work silent and solo, and I will see you tomorrow again for, reminder, Pajama Day. Have a good day.